Yeah, good morning, students. I'm here to tell you about the determinants. This is our first unit. So, what is the meaning of determinant? Determinant means it is the square arrangement of element and it is having a magnitude value. Now, what will be the outcomes for learning? After doing this first unit, the student means you can define the determinant and understand their relations of matrices, and you will be able to explain the methodologies of determinant. And obvious, you will be you can solve other minors that will be related to the higher matrices. So, as I told you earlier, what is the meaning of a determinant? A determinant is the scalar value of a square matrix. Means if we are having a square matrix, we can define the determinant corresponding to that matrix. Okay. Corresponding to the rectangular matrix, we cannot define the determinant. So it is a scalar value for square matrix. So for any square matrix, means if we'll talk about the notation of the square matrix, we generally denote that square matrix with a capital letter. Generally, we can say A, capital A, and when we are doing the notation of that, we are denoting the elements of the square matrix in Aij, where I is ith row, J is jth column. So if I'm saying a matrix having Aij elements, means I'm talking about the element is there which is placed in ith row and jth column. Okay. So we can associate a number, whether it is a real or complex, called determinant of the square matrix, where Aij is the ith row and jth column element. So now we are coming to the notation of the determinant. The matrix is having the braces, means all the elements of the matrices are written in between the braces, like we can say the large bracket. Okay, but when we are going to denote the determinant, that will be in between the straight two or straight line. We can say that is the bracket of the straight line. Okay, so we should be very much aware whether we are writing the determinant or we are writing the matrix. Matrix is what I told you. It is a square arrangement in rows and column. Then corresponding to that matrix, we can calculate the determinant. And obvious, if the matrix is square, then we can calculate the determinant. Otherwise, we cannot. Okay. So if we are going to find the determinant, means we are having, for example, 2 cross 2. If I'm saying 2 cross 2 matrix, means there are 2 rows and 2 columns. Okay. So total number of elements will be 4. Means in the single first row, there are 2 elements. And in the second row, there are 2 elements. In the same way, column also, likewise. So how we will calculate the determinant? For the 2 cross 2 matrix, we can do the simple multiplication, cross multiplication, means A11, the element which is in the starting. A11 will be multiplying to the A22. We can do diagonal element. Okay, A11 into A22 minus A12 into A21. Okay, when we will be doing the numerical, then definitely we will be okay with the calculation. Whenever we are calculating the determinant, we have to start with the diagonal element, means the very first element. It can be A11 or anything else. Okay. So as I told you, we can calculate the determinant of 2 cross 2 matrix. Similarly, we can calculate the higher order matrix also, the determinant of higher order matrix like 3 cross 3 and 4 cross 4, 5 cross 5. But we should be aware whenever we are going to 3 cross 3, means again we are taking the first element. When I'm saying 3 cross 3, it means there are 3 rows and 3 columns. When I'm saying 3 rows, means the horizontal arrangement is known as rows, while the vertical arrangement is known as the column. So lesser one will be of 2 cross 2, one more minor is there. This way we can find multiple minors, means we are going to now delete first row and second column. So we will be having the leftover element A21, A31, A23, A33. So these four elements are there. This is again a minor. Okay, so this way we can find the minors of the determinant. Now, as we are having 3 cross 3 value, 3 cross 3 arrangement, so the largest minor is of 3 cross 3, then 2 cross 2, then 1 cross 1. And yes, no minor will be there less than 1 cross 1. Okay. So minor of an element of a determinant of order n is the determinant of order n minus 1. Like what is the meaning of this? Like if we are having a 3 cross 3 arrangement, we are going to find the minor. Minor means that is the n minus, means 3 cross 3 it is n. So 3 minus 1 it is 2. So we will be having the minor of 2 cross 2. So for expanding the determinant, we can write A11 means the element first one, M11 the minor of 1 cross 1 minus A12, then M12 plus A13, then M13. Now we are coming to the cofactors, as the cofactor are associated with the determinantal thing. So cofactor means we are calculating the Mij. We can denote that Mij, and in some books it is written over like Cij. No need to worry about that. If we are having 3 cross 3 matrix or 3 cross 3 determinantal arrangement, then we are having a 9 elements. Okay, it means first element is A11, and in the diagonal we will be having A22, in the diagonal we will be having A33. Okay, now what we are going to do? We are going to do the cofactor for this 3 cross 3 arrangement. So as we told in the starting, we are going to calculate the determinant. So in the very starting, the first element is of minus 1 to the power I plus j. So it is I, A11, I is 1, j is 1, 1 plus 1, 2, minus 1 whole square, it is plus. Means first element will be taken as positive, then second will be negative, then positive, then coming to the second row to the first element means A21. Means the value of I is 2, j is 1. So minus 1 to the power 3. So minus 1 to the power 3, it is cube. So odd, it will be negative. So in the second row, first element will be of negative, then positive because 2 plus 2, 4. Then third is again negative because it is 2, 3, again odd. Then coming to the third row, we will be having 3, 1, it will be positive, then 3, 2, it will be negative, then 3, 3, it will be the positive. So this way we can write the cofactors of a determinant. So how many cofactors will be there? If we are having 2 cross 2 determinantal arrangement, so we can denote one cofactor as A11, another cofactor as A12, another next one cofactor as A21, and last cofactor as A22. So how many cofactors will be there? 4. Similarly, if we are having a 3 cross 3 matrix, and corresponding to that matrix, we are having a 3 cross 3 determinantal arrangement. So how many cofactors will be there? 9. Okay, because 9 elements are there. Okay, so there are some interesting properties, and obvious if we are discussing the determinant, we should be very much careful about the properties of the determinant. So the sum of the product of the element on any row or column with the corresponding cofactor is equal to the determinant of the matrix. It's a very interesting thing. So the determinant of 3 cross 3 matrix will be what? We are having first element into the cofactor, first cofactor plus second element, that is A12, multiply with the cofactor of A12, and then plus A13, then cofactor of that A13. We will be having the result. Okay. So if element of a row or a column multiply with the cofactor of any other row, okay, then their size will be 0. Now we are coming to the singular and non-singular matrix. Okay, so we have discussed earlier also, as we are talking about the determinants, we are going to find the determinant for the matrix, and the matrix will be having a determinantal value. We can say the magnitude will be there. That may be 0, that may be non-zero. So if a 0 determinant is there, the matrix will be known as singular, and if it will be having a non-zero determinant, it may be positive or negative, no need to worry about that. But if we will be having a non-zero determinant, the such matrix will be known as non-singular. So there are two basic results that are to be used in the theory. So if A and B are non-singular matrices of the same order, then AB and B are also non-singular. Means if we are having a A matrix of 3 cross 3, B matrix of 3 cross 3, both are non-singular, we are going to multiply these two matrices. Okay. So the result will be either AB or BA. Although this AB and B are not equal in some sense, but we can find AB and BA. So the resultant matrix will be the non-singular itself. Okay, so the determinant of the product of the matrix is equal to the product of their respective determinants. Like if we are having a matrix A and we are having a matrix B, the order can be anything, we cannot say anything, because for the multiplication we should be aware that n cross n, one matrix will be having n cross n, then the column of this matrix will be equal to the row of the second matrix. So we can do the multiplication. Otherwise, multiplication will not be calculated. So we are having A matrix, it is of 3 cross 3, B matrix, it is of 3 cross 3. We can do the multiplication, and after multiplication, we will be having a resultant matrix. So we can say that is C matrix. Okay. Now we are going to find the determinant of that C matrix. Okay, so interesting thing is the determinant of that C matrix will be equal to the determinant of individual A matrix into the determinant of individual B matrix. So the determinant of C will be is equal to the determinant of A into determinant of B. Okay. So there are some few more properties about the determinant. The value of the determinant will not be changed. It's very interesting. Means if we are going to interchange two rows or two columns, means we are having a first row, we are going to change that row over the second one and second to the first one. There are some kind of a notations. Means we are going to change Rij to Rji. We are changing ith row to jth and jth to ith, vice versa. So when we are going to change the row and column of any determinant itself, so the value of determinant will be remain same, it will not be changed. Okay. One more interesting property is with us, means if we are having a squirrel arrangement, we are going to find the value of that, as we have already discussed how we will calculate. Now we are going to calculate the transpose of that squirrel arrangement. What is the meaning of a transpose? Means if we are having a first row, second row, third row, now we are going to change this arrangement into first row as a first column, second row as a second column, third row as a third column. So the resultant will be known as the transpose. Okay. Now if we are going to find the determinant of this squirrel element and its transpose, the both will be equal. The property is known as the reflection property. It's a very interesting property. The value of the determinant, if we are going to multiply any scalar to the row of any matrix or column of any matrix, then the value of the determinant will be remain same. So it will be known as switching property. We are going to multiply with some like a -1 scalar multiplication to the row or to the column. So whenever we are going to multiply this scalar quantity, the scalar quantity will be multiplying to each and every element, whether we are multiplying in row or whether we are multiplying in column. So the value of the determinant can be 0. Yeah, there are some interesting property. Means we may have a big determinant, okay, and obvious we are aware to finding the process of the determinant, but we can say instantly we can talk about the value of that determinant. How? Like if the determinant of any square element is 0, then it may be means all the elements of any column or all the elements of any row are 0. Okay, so that elements in two row, the first property I told means if we are having all 0 elements in a row or in a column, then resultant determinant will be 0. Second is we are having a square arrangement, means we are having a determinant in which the first row is having like 1, 2, 3 element. In the second row, we are having 1, 2, 3 element. Okay. So, and third row, we may have -1, 0, 1. Okay. These are the elements. Now you will see we are having 2 row, both are same. So, if we are having any arrangement or any determinant which is having 2 identical row or the same case 2 identical column, then the value will be 0. Okay. So all element, one more property, if we are having all the elements of determinant is 0, then definitely that will be the determinant value will be 0. That is known as all 0 property. Okay. One more property is with us, like if we are having a determinant like 1, 2, 3, then 2, 3, 4, then 3, 4, 5. Interesting it is. In the first row, we can see 1, 2, 3. Then 2, 3, 4. Then 3, 4, 5. The second element is the first element of second row. And the second element of second row is the first element of third row. If we are having such kind of arrangement, then the determinantal value will be 0.